A very interesting thing that some of these brands for cloud computing are bringing together is breaking with the usual formal training. So I open up this talk with the production of bachelor degrees. In theory, a bachelor degree is something that takes 8 semesters or 4 years. In practice, many undergrad students take longer than 4 years, 5, 6, in some cases 7. So, but even if it were 4 years full time, that's a very specific formal training. So you have labor force currently employed. We also saw that table in which people are landing employment in areas that are outside of their formal degree. So there is sometimes transition and evolution as to I have a degree on this, I get employment in another area, and then I start moving, in different sectors or different trajectories. So it's unrealistic to think that we are going to have a chemist or a biologist become, specialized with some set of skills, and then this person will have to pause their employment, go back to school for a number of years, and then come back to the workforce. Instead, there are schemes that are based, they're called micro-credentials. They're based on something like merit badges. I was a Boy Scout, and I know Boy Scouts and Girl Scouts are probably, pioneers in this concept, this idea of merit badges. So the micro-credentials kind of are based on that. So here, again, many of you may know about this, many of you maybe don't know, but there are multiple, this looks like an infomercial maybe, but I just wanted to have this here. I would say AWS Educate has not only badges, but also pathways. There is another platform called Kaggle. Kaggle is the parent company. The parent company of Kaggle is Google. But this platform has a division called Kaggle Learn, and they have micro courses, and you can also earn certificates. And places like LinkedIn Learning, you will find basically like a catalog about data science training, and the usual MOOCs, massive open online courses platforms, edX. There are many of these, but I just mentioning edX and Coursera, where you can also find actual courses. So these are all very wonderful resources. And as an illustration, in my home institution, based or inspired by these schemes of micro-credential trainings, my home institution, East Tennessee State University, in our catalog, we have a minor in mathematics and a minor in statistics. The minor in mathematics is quite flexible. So it's just stated as a minor in mathematics. So basically, students can create their own flavor. It could be more in the pure math flavor, or it could be more in the applied math. So I worked, and you see the reference here, and I'll be more than happy to share with the attendees. You drop me an email and I'll be more than happy to share copies of my slides that have hyperlinks. And so my collaborators and I put together a proposal for national scale adoption, in which we're recommending, look, at our institution, a minor is 7 classes. You think about it, 7 classes over 8 semesters is almost 1 class per semester. And really, on the left side here, we have a flavor of a minor that's more on the computational applied mathematics side, with things that include mathematical modeling, stochastic modeling, and algorithms for numerical linear algebra, like singular value decomposition, image compression, those kind of things, principal component. On the right side of this schematic, we have a minor that's more on the side of statistics or applied statistics, with things like statistical modeling, statistical machine learning, and Bayesian analysis. And so basically in that publication, our proposal is in your home institution, if you can create a version or merging some of these flavors, then you would come up with something similar to what we're proposing here, which is inspired by those micro-credential schemes.